Hello. This video is for IXL activity 6.Z.8. It is titled Solve One-Step Multiplication and Division Equations with Whole Numbers. The three-character code for this activity is Juliet Uniform Alpha, JUA. All right, so we're going to be solving some equations. It only takes one step to do it. And it happens to be that all of these problems are going to involve multiplication and or division. And in the textbook lesson, we learned that you can undo division with multiplication, and you can undo multiplication with division. This is because multiplication and division are inverse operations. I like to say the opposite operation. So whenever I say opposite, understand that I'm basically substituting the word inverse. I know the correct word is inverse operation. I prefer to use the term opposite operation. So the idea to solve an equation is to isolate the variable. If you're on an island all by yourself, nobody else there, like Tom Hanks, then you would be isolated. So we want to get the variable all by itself on one side is the goal. So let's go ahead and take a look at our first problem. We can see that the v is tied to the 3 through division. The opposite operation of division is multiplication. And we're going to multiply by the very number we wish to get rid of, which at the time is this 3, because it's tied to the, change my thickness of my pen there, because it's tied to the v through division. And what we do to one side, we need to do to the other. And why I wrote a 2, I do not know. I'm just having a hard time getting my head in the game today. So the 3's will cancel each other, and the reason for this is think of 3 as 3 over 1, right? And then we would end up with, do I want to go over this again? Yes, I think I will. I went over it in the lesson for the textbook. So the reason that the 3 just like disappears and whenever I say that they cancel one another is, I'm going to rewrite it down here. If I have v over 3 and I multiply it times 3, well, this is equal to v over 3 times 3 over 1. And because we can put any number over 1, it still equals itself. If we multiply fractions straight across, we would have 3. We get 3 times v. And here, I'm just going to go ahead and write 3 times 1 here. And I'm not actually going to multiply it. I'm going to leave it just like it is there. So it's still the value of 3. And now I'm going to go ahead and rewrite this back into 2 fractions times each other. So we end up with 3 over 3 times v over 1. And then that is equal to, well, 3 over 3 is equal to 1. And v over 1 is equal to v. And anything times 1 equals itself. So we end up with v. So you can see here that we start off with v over 3 times 3 is equal to, and then it ends up just being v. So it's not any kind of magic. It's just all these mathematical principles and rules for math that are being applied there. So on one side I end up with v, and then 4 times 3 is 12. So v equals 12. So whenever I just say the v's cancel each other, it's not like magic. It's actually math principles taking place there. So just want you to understand that. All right, so 9t equals 72. So the 9 is tied to the t through multiplication. The opposite operation is division. Every fraction is a division problem. We're going to divide by the very number we want to get rid of, which is 9. And what we do to one side, we have to do to the other side as well. So these 9's are going to just cancel each other. And you're like, well, what do you mean the 9's just cancel each other? Well, let's take a look at that. So, and it's just going to equal t. So let's look at how 9 over t, or 9t over 9, ends up equaling just t. Well, if I write this, I could write this as 9 over 9 times t over 1. So I've just done this. This is like putting 2 fractions together, and now we're taking the 2 fractions apart. And now we have 9 over 9 equals 1. T over 1 equals t. And 1 times t equals t. So this is how we get from 9t over 9 equals t. So again, whenever I cancel those 9s, it's not magic, it's math. And so we end up with just t, and 72 divided by 9 equals 8. All right. I probably won't go through all of this in the following problems and examples. I just want you to know that whenever I say they cancel each other, I want you to be able to understand exactly what's happening there and where's the number going. It is math, not magic. So I'm going to rewrite. Good mathematician always rewrites the problem. So 3d equals 75. The 3 is tied to the d through multiplication. The opposite operation is division. And we're going to divide by the very number we wish to get rid of, which is 3. And what we do to one side, we're going to do to the other. The 3's are going to cancel each other, leaving us with just d on the left. And 75 divided by 3, well, that's 25. So d equals 25. On the next one, g over 5 equals 6. The g is tied to the 5 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is 5. And what we do to one side, we have to do to the other. So the 5 is going to cancel each other, leaving us with just g. And 6 times 5 is 30. Here we have w over 28 equals 15. So the w is tied to the 28 through division. So the opposite operation is multiplication. And we're going to multiply by the very number we wish to get rid of, which is 28. And what we do to one side, we are going to do to the other. So the 28 is going to cancel each other, leaving us with just w on the left. And we have to do 15 by 28. 28 times 15. All right, so 5 times 8 is 40. And 5 times 2 is 10, plus the 4 is 14. And 8 and 2. Now we need to add these together, right? 0, 12, carry the 1, and it should be 4. All right. I'm sure I got a few chuckles from the viewers out there today for that answer. At least I did for my students in Alaska. So here we have, I want to point out over here that this is a good demonstration of if you ever want to get rid of a fraction, just multiply both sides and everything by its denominator. Gets rid of the fraction for you. So 13v equals 819. So the 13 is tied to the v through, that's right, multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of. And what we do to one side, we have to do to the other. So the 13s are going to cancel each other, leaving us with just the v, but we now have 819 divided by 13. So 819 divided by 13, and yes, you could grab a calculator for this, but 13 into 81, 15 goes into 75 like 5 times. So I think I'm going to try 5 first. 5 times 3 is 15, carry the 1, 6, right? 65, 75, 8. Ooh, I can get a 6th one in there. 6 of them will fit. I think I can get 6 13s in there. So let's try 6 instead. 6 times 3 is 18. Carry the 1, 6, 7, 6 times 1 is 6, plus the 1 is 7. And 81 minus 78 is 3. Bring down the 9. 13 goes into 39 3 times. And that's going to equal 39. And we'll have 0, so we're at 63. Okay. Next one. Solve for j. 765 equals 9j. So the 9 is tied to the j through multiplication. The opposite operation of multiplication is division. We're going to divide by the very number we wish to get rid of, which is 9. And what we do to one side, we have to do to the other. So that's right. The 9 is going to cancel each other, leaving us with just j. And now I need 765 divided by 9. 9 will go into 76 8 times. That'll give us 72. And then bring down the 4 and the 5, and 9 goes into 45 5 times, and that's 45. And we're now at 0, so we're done. So it is 85. And for my last question, the k is tied to the 28 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, is 28. And what we do to one side, that's right, we have to do to the other. So the 28s are going to cancel each other out, leaving us with just k. I now have to do 28 times 6. I could have probably mental math that, but I'll go ahead and work this out. 612 plus 4, 16, 168. Let me see, 120. Yep, 168. Yeah, actually checked my handwriting math with my mental math because I trust my mental math more sometimes. Okay, so those are all of my examples for IXL 6.Z.8. Solve one-step multiplication and division equations with whole numbers. Good luck on your activity.